Assalamualaikum warahmatullahi wabarakatuh. Today I will be presenting about 3-bit down counter using Verilog. This project was provided by me, Amir Hakim Mitazuddin, and my other teammate, that is Muhammad Mazwan, Mohamed Nazim, Muhammad Anas Ikhwan, Muhammad Arif Ong, and Muhammad Shafiq. So we will go to the introduction. So in this project, Verilog code for 3-bit down counter with testband will be presented. To begin with, this project is about 3-bit down counter that reset the cycle using D flip-flop asynchronously, meaning it's come from 7 state to 0 state by decreasing 1 state per 1 state. The reason all the feature above has been chosen because they are the quickest to be completed. As for the tool, we are using the Xilinx Vivado, and the edition was ML standard. We also use Microsoft Visio and Microsoft Word. So the process took place in the synthesizable code and test bench code. Uh, so the flowchart is we start with test bench code flowchart planning, synthesizable code, and test bench code programming, the schematic circuit designing, and ended with simulating waveform diagram as an output. So programming wise, Verilog has been set as a language for the programming the whole code as it's suitable for beginner, where the behavior, style, and model has been implemented for programming the synthesizable code. Interestingly, down counter and alike has been one of the most important key items used in fabricating powerful chip since a long time ago. Next.
Assalamualaikum and have a good day. My name is Muhammad Shafiq bin Shahri and my number matrix is B122310126 and I will present about synthesizable flowchart. So from here we can see the start and the end. This is very simple flowchart. Okay, you can see here counter start reset or no, and then if yes, it will be counter set or 111 at starting point. If not, if counter start at if counter not start at reset, it's like a preset, it will be decrement, and then it will be subtract 111 which 001 to do decrement. And that's for the flowchart.
Next, I will be talking about the test bench coding flowchart. So before I start, I will tell you the meaning of this test bench code. So test bench code is a step to be complete. Uh, sorry, test bench is a step for the compiler to check either is the coding is right or wrong. So I will start with the flowchart. So the flowchart start will be start, and then it will declare the input and output for module down counter test bench. So when the initial clock is 0, then clock is 1 after then the clock will be 1 after 5 nanosecond when the counter start. So it will take 5 nanosecond for the clock to change to 1. Next, for initial reset, from 1 it will take 20 nanosecond, and then it will reset to 0. Next it will end the process. That's all from me.
Hello, good day. My name is Muhammad Mazwan, and I will explain to you guys about synthesizable code or main code. So, firstly, on the line 1, we set the time scale of nanosecond per unit, and then line 3 to 4, we put input and output declare, and then line 7, we positive edge of clock or positive edge of reset stay as always, or the time has been selected because clock waveform and reset waveform are not combined together, and the always has been used because the both waveform of clock and reset will run continuously to realize the sequential operation of the D flip flop. Next, on the line 8, the starting of the down counter operation is indicated by begin. On the line 9 and 10, the operation that the moment will count, select the first state, is indicated by reset. And then following that, the value of output, which is counter down, is insert by the number 3 apostrophe B11, which is 7 state, using the non-blocking symbol to show you that the counter will start at 111 in the binary. On the other hand, the reason reset is on if the condition, because the reset is denote the starting all over again. On the line 11 and 12, the operation that the counter will count down is indicated by else condition. Each statement is defined as a down underscore counter to down counter minus 3B001. Denote that the output counter down that will be decreased by one value or one state that is defined by minus 3B001. Lastly, on the line 14, assign counter equals counter down is implemented because this is the statement represent the subtract operation from the down counter to 3B001 in the flip-flop. So this is all for the coding, and thank you.
Good day everyone, my name is Ahmad Mohamed Azim and I will explain test bench code for 3-bit down counter. Line by line. Line 1, firstly timescale of 1 nanosecond per unit is set. Line 3 to 6, module declaration of test bench is made. Inside this, register clock, reset will be declared. Register is variable that stores data of the clock at reset during simulation. Next, wire 220 counter is a declaration of output, where 220 means 3 bits and wire is variable for connectivity between clock and reset. Line 8, declaration of submodule of DUT designed under test bench. This is where all of the process of testing done by test bench. Line 9 to 11, this is where the clock timing will be created. The starting moment of clock, which is 0, is indicated by clock equals 0. The clock timing diagram is set to rise for every 5 nanosecond and is defined by forever #5 clock equal clock bar, where forever means endless run, #5 means clock will stay its position of staying rise for 5 nanosecond, and clock bar means 1. Lastly, line 13 to 16. This is where the reset timing will be created. Since we prefer to not have a active low reset, the reset value is assigned #0 when the reset is equal 1. Whereas when reset is equal 0, no statement is needed as the compiler will assign reset equals 0, continuing from reset 1. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Next, we go on to schematic circuit. Based on this figure, which is figure 5, the schematic circuit of asynchronous 3-bit down counter using the flip-flop that is obtained. It is automatically generated by program Z-Link, which we use in our project, Z-Link Vivado ML standard version. The circuit comprised of clock, reset, circle object, which represents subtraction operation. For unit of stack D flip-flop labeled as RTL, registration, and asynchronous. So you can see this figure. We refer on this figure. Not to confuse to have for units flip-flop. These are just representation. And output label for this schematic circuit is 2/0. RTL means how data is transformed as it is passed from register to register, described by Verilog code. REG, which is stands out for register. The flow of this counter can be understood by observing the figure 6 and figure 7. As you can see, this is figure 6 and this is figure 7. This is our circuit and this is our truth table. So that's it for our schematic circuit.
Okay, good day everyone. My name is Muhammad Harid Ong. Today I will explain about simulation for down counter waveform. So after putting the coding about test band coding and coding, so we just run simulation. Okay, about this waveform, we get for 7 and go down until 0 and we will reset back. So based on the simulation, the waveform of the flip-flop 3-bit asynchronous down counter with reset has been obtaining according to main code and test bench code. The waveform is located on the MOS below. In Xilinx Vivado ML Standard Edition, the waveform of the output is compressed into one waveform shaped into hexagon. The waveform of counter starts from 7 state labeled 7 at 1 nanosecond and decrease 1 state per 1 state until it reaches 0. Then the counter reset at the counter will start to 7 state until reach 1000 nanosecond, since we set the waveform to stop at 1000 nanosecond. Okay, that's all.
Okay, Assalamualaikum and good day. Have a good day. My name is Muhammad Shafi bin Shahri and my number metric is B1223101226. Today I will be present about our conclusion. So in our conclusion, this project or our project has been achieved as per objective. As a result, a 3-bit down counter that counts 1 bit in decrement from 7 to 0 and reset. It is learned that various sequential and combinatorial circuits can be made by using Verilog language on Xilinx Vivado ML Standard Edition. Although full version of Xilinx Vivado ML Standard provide more comprehensive and exclusive features, nonetheless, deep comprehension of programming knowledge in programming Verilog. For example, if-else statement, case statement, and so on, would be advantage or for any student or engineers who seek to expand their experience and skills in field programmable gate array, or in bracket FPGA designing. For further improvement, few other sequential or combinatorial circuit, for example, shift register and multiplexer respectively, can be performed and simulated to grasp the improve the fluency of Verilog programming. Similarly, the code also can be implemented on VHSIC hardware. Description language VH or in bracket or VHDL to observe the difference in terms of the way of the code are programmed. All in all, Verilog has a better grasp on hardware modeling but has a lower level of programming construct and thus suitable for beginner skills. Thank you. It's our in the slide you can see uh, our result from full waveform view by hand is this, and then this is from our software Vivado. We can get the output waveform in this is the same as we analyze. So if you can see here, this is full waveform view by hand. This is so like manual handwriting, and then this is from Vivado ML. It's the same output as our review by hand. Okay, thank you.